So we have a system of inequalities that we want to solve. And you need to remember that when you're told to solve a system of inequalities, remember inequalities because we see the greater than or less than or equal to signs, that when you're solving a system of inequalities that you're not really doing any algebra, but rather these have to be solved graphically because we're looking for all the possible x and y values that satisfy both of these inequalities. So we recognize there are going to be an infinite number of ordered pairs of x and y values that will be true for both of these inequalities. And that's why the solution is going to be a set of ordered pairs that's going to be represented on the graph by a shaded region. So we need to graph both of these curves. So first we want to look at the first curve and decide what type of a curve this is. So my top curve here is a parabola. So we're going to begin by graphing the parabola y is equal to 2 times the quantity x minus 2 squared minus 4. Now, the less than or equal to sign, that's going to help us shade later, but first we have to graph the parabola. So helpful to notice that this parabola is in vertex form, so we can identify the vertex. We see that it's been shifted to the right 2 and then down 4. So my vertex is going to be at 2, negative 4. Then also helpful to remember that this parabola opens up because of the positive leading coefficient. And because the leading coefficient is a 2, we recognize that there's a vertical stretch. So thinking about the general shape of our parent function, y equals x squared, typically from that vertex, we go to the right 1 and then up 1. And then from that point, we go right 1 and then we go up 3. And then from that point, we'd go right 1 and we go up 5, remembering that we're going up all of the odd numbers. So because we have a coefficient of a 2, then all of these odd numbers get multiplied by that coefficient of 2, and that is therefore the number that we will travel up each time. So from the vertex, we'll travel right 1, but then, we will go up 2. And then from that previous point, right 1, and now we'll go up 6. So going back to my parabola, starting at the vertex that we have at 2, negative 4, we're going to go to the right 1, and then we're going to count up 1, 2, and that's my next point on my parabola. And we can do that moving to the right, and then as well to the left 1, and then up 2. And there's my next point. Now we start on this new point, and we go right 1, but we're going to go right 1, here it is. Now we're going up 6, 1, 2, 3, 4, 5, 6, and you go, here's my next point on my parabola. I'll erase all these little jumping notations, as well as the other direction, left 1 up 6. And we see that it's this nice kind of thinner, more narrow looking parabola, which was expected because of the vertical stretch. Now, let me pause for a second because I just drew in this parabola in a hurry and I made it a solid parabola, but let's go back and take a look at our inequality sign here. Because it is less than or equal to, it's that equal to that makes this parabola solid. So that's how we're going to graph our first parabola. Before you move on to graphing the second parabola, I recommend that you go ahead and determine the shading on this first parabola. So, to determine whether you're going to shade inside the parabola or outside the parabola, I recommend that you pick a test point. So we're going to test some point, and you could pick any point on the coordinate plane other than the points that lie specifically on the parabola, but the easiest point to choose would be 0, 0. So I'm testing to see if 0, 0 is a solution to this first inequality. So I'm going to substitute in 0 for y as well as 0 for x. And I'm interested in knowing, so I like to put sometimes a question mark over the inequality sign, is 0 going to be less than this quantity? So let's go ahead and simplify the right-hand side. So we'll end up with negative 2, the quantity squared. That will give us positive 4. So 4 times 2 is 8, and 8 minus 4 is going to leave us with 4. So we get this statement, 0 is less than or equal to 4. And this is a question mark. Is this true? Is 0 smaller than 4? And the answer here is yes, absolutely. This is a true statement. So because we got a true statement, what that means is the point that we tested is a solution. So that means that this point, 0, 0, it is a solution. So when we go to shade where all of the other solutions are, we're going to include 0, 0. So now looking at my parabola, you'll notice that 0, 0 lies outside of the parabola. So when I shade, I'd be shading everything here on the outside of this parabola. Now I'm not actually going to shade all of that because my graph gets a little messy that way. So I prefer just to do this little notation. I draw a couple little arrows indicating, okay, here's where my shading will be. My shading is going to be outside this parabola. And then I'll do my real shading once I graph the second parabola. So now we want to graph our second parabola, and we'll graph y is equal to negative x squared plus 2. And this one is also in shifted form or vertex form. So remember that you can think of this as negative quantity x minus 0 squared plus 2, if that helps you to recognize that there has not been any shift left or right. So in other words, my vertex here is at 0, 2, or this is a parabola that's just been shifted up 2. So up 2, I have my vertex of the parabola. Then because of my negative leading coefficient, the parabola opens down, and there has not been any sort of a stretch or compression. So from the vertex, I'm going to travel to the right 1 and down 1, and then left 1 and down 1 to get my next 2 points. And then from each of those points, I will travel right 1 down 3, and then left 1 down 3 to get 2 more points. And 5 points is certainly enough to draw your parabola. But don't just draw it in. Once again, you have to pay attention to the fact that this was a greater than, not a greater than or equal to. So this parabola is actually going to be dotted, meaning that the points that actually are on the parabola are not solutions to this particular inequality. So you'll have to make that dotted or perhaps erase if you had already drawn in something that was solid. And now we're back to needing to test to figure out where the shading is going to be for this inequality. So now let me go all the way back to the original inequality that we were given, and we're going to test a point. Once again, you could test any coordinate you want. It's always nice and easy to test 0, 0. The only time you can't test 0, 0 is if 0, 0 actually lies on one of your curves. So we'll test 0, 0 by substituting in 0 for y, and then we're wondering if it's going to be greater than, so question mark, and now substituting 0 also in for x. So we'll end up with 0 is greater than 0 squared, so that's just going to be 0 plus 2. So my statement is 0 is greater than 2. And that's what we want to know. Is this true? Is 0 greater than 2? And this is a false statement. That is not true. So again, we were testing 0, 0, and what that means now is that 0, 0 is not, it is not a solution for the second inequality. So when we go to shade on the second parabola, we do not want to shade over 0, 0 because 0, 0 is not a solution. Now if you go look at your second parabola and locate 0, 0, 0, 0 is here inside this dotted parabola. So we don't want to shade inside the parabola. Since 0, 0 is not a solution, we want to shade outside. So now we're wanting to shade outside the parabola, that's dotted. And your final answer to this system of inequalities is where the two shaded regions overlap. So we're looking where the shaded region from the first parabola, so everything outside the first parabola, but then where does that overlap with everything that is outside the second parabola? So if you were doing this in colors, I might choose then a third color to go, okay, where are they going to overlap? Well, I would include everything here that's outside this first parabola, but then down here I'm choosing everything that is also outside the second parabola, so that would be that region. And then on the right hand side, this is everything outside the first parabola. Coming down here and including everything also outside the second parabola. So this blue shaded region contains all of my solutions, and there's an infinite number of them.